Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic: field components in rectangular waveguide. Lecture level outcome. After completion of this lecture, the student will be able to derive the field components in rectangular waveguide. Recap. Notation for wave propagation in open space. Consider an EM wave traveling in open space in positive z direction. It has dou by dou z is equal to minus gamma, and dou by dou x equal to 0, dou by dou y equal to 0, dou square by dou z square is equal to gamma square, Ez equal to 0 and Hz equal to 0. And these values Ez equal to 0 and Hz equal to 0 are valid only for the wave traveling in open space, not in waveguide. Now, the notation for wave traveling inside the waveguide. The wave traveling inside the waveguide, Ez and Hz depends on the type of mode it is. If it is a TM mode, then Hz is equal to 0. If it is a TE mode, Ez is equal to 0. And for TEM mode, Ez equal to 0 and Hz equal to 0. For rectangular waveguide, the dimensions along X and Y are A and B respectively. They are finite. So dou by dou x is not equal to 0, dou by dou y is equal to not equal to 0, and the wave is traveling along positive z direction. Dou by dou z is equal to minus gamma. If the electromagnetic wave is traveling along negative z direction, then the gamma will be positive. Dou square by dou z square is equal to gamma square. And for parallel plane waveguide, the separation between the planes along x-axis is equal to a, and the waveguide is infinitely extended along y-axis. For that reason, dou by dou x is not equal to 0 and dou by dou y is equal to 0. As the waveguide is infinitely extended along y-axis, the field components are assumed to be constant with respect to y-axis. For that reason, we consider dou by dou y equal to 0, and the wave propagation is along positive z direction. Dou by dou z is equal to minus gamma, and dou square by dou z square is equal to gamma square. Once refer to the notation, wave propagation in open space and wave propagation in rectangular and parallel plane waveguide. Field components in rectangular waveguide. Consider an EM wave traveling in rectangular waveguide along positive z direction. The space inside the waveguide is filled with source-free, lossless. Source-free means J equal to 0. Lossless dielectric material. The conductivity is 0. The walls are perfectly conducting. It is a rectangular waveguide which is made up of a good conductor. The walls are perfectly conducting. Thus, it is a hollow conducting tube. The space inside the waveguide is filled with source-free, lossless dielectric material. Based on that, if we substitute the property of propagation of wave inside the waveguide, the Maxwell equations become del cross H is equal to j omega epsilon E 1a, del cross E is equal to minus j omega mu H 1b. The two equations 1a and 1b plays key role in deriving the field components for rectangular waveguide. Here, the E field component and H field component are given in equation 2. Now expand 1a, 1a del cross H is equal to j omega epsilon E. By expanding 1a and equating the coefficients of ax, ay, and az, we get equations 3, 4, and 5 respectively. From 3, if we separate ex, we get equation 6, ey, we get equation 7. Similarly, we can further proceed and expand 1b in the next slide. Expand 1b, equation 1b. Expanding 1b and equating the coefficients of ax, ay, and az, we are going to get the equations 8, 9, and 10 respectively. And from equation 8, we can separate hx, which is given as equation 11, and from 9, we can separate hy, it is given as equation 12. The field components are ex, ey, hx, and hy. We are going to derive the field components ex, ey, hx, hy in terms of ez and hz only. Now substitute 12 in 3 to get the field component ex. Substitute 12 in 3 and rearrange. We get equation 13. Multiply equation 13 with j omega. We get equation 14. From equation 14, if we separate ex, ex is equal to minus gamma by h square dou ez by dou x minus j omega mu by h square dou z by dou y. It is one field component, electric field component along x-axis. Similarly, we can determine ey, hx, and hy. Here, minus omega square mu epsilon minus gamma square is represented by minus h square. Here, h square is equal to kx square plus ky square, where the value of kx is m pi by a and ky is n pi by b. AB are the dimensions of the rectangular waveguide. M and N depends on the mode propagation inside the waveguide. M and N are constants. Similarly, substitute 11 in 4 and after rearranging, we are going to get Ey is equal to minus gamma by h square dou Ez by dou y plus j omega mu by h square dou hz by dou x. Electric field component along y-axis in rectangular waveguide. Substitute 7 in 8. Magnetic field component along x-axis given in equation number 3. The last field component is Hy. Magnetic field component along y direction. It is given in equation 4. Equations 1, 2, 3 and 4 are regarded as field components in rectangular waveguide. You're supposed to remember the field components in a rectangular waveguide: Ex, Ey, Hx, and Hy in terms of Ez and Hz only. Uh, to further proceed regarding TM wave propagation and TM wave propagation in rectangular waveguide, these four equations are base. Field components in rectangular waveguide. Here I will tell you how to remember the field components in a rectangular waveguide: Ex, Ey, Hx, Hy. Remember the notation: minus, 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 plus, minus, plus, and minus, minus. For Ex, the first term for all the field components, gamma by h square, gamma by h square. Then for Ex, dou Ez, x, dou x. And for the next term, minus dou hz. Here dou ez is over, the next term is dou hz. Here x is over, the next is dou y hz j omega mu by h square. You're supposed to remember for h, you're supposed to substitute mu. For e, you're supposed to substitute epsilon. In the same way, ey dou Ez by dou y plus dou hz. Ez is over hz, y is over dou x, and j omega mu by h square. Hx dou hz by dou x. The remaining terms are dou Ez. Here x is over y. Sorry, it is Ez. Hz is over Ez. Dou x is over dou y. For E electric field, j omega epsilon by h square. Like that, dou hy, dou hz by dou y minus j omega epsilon by h square. Hz is over dou Ez y is over dou x. In this fashion, you can remember the field components in rectangular waveguide. These equations are very important in TM mode, TE mode propagation in rectangular waveguide. Refer to the summary. The sample questions are: derive the field components in rectangular waveguide. You are supposed to derive the field components Ex, Ey, Hx, and Hy. The field components are in terms of Ez and Hz. It is very important. The next question is TEM mode cannot propagate in rectangular waveguide. Justify the statement. For that, you are supposed to determine the field components in rectangular waveguide Ex, Ey, Hx, and Hy. The field components are in terms of Ez and Hz. For TEM mode, Ez equal to 0, Hz equal to 0. Uh, all the terms are 0, which means TEM mode cannot propagate in rectangular waveguide. Thank you. We will meet with the next lecture.